So I'm going to talk about using small cells, femtocells and picocells, to provide extra capacity in the mobile network to handle the data explosion. First of all, just a very quick introduction to IP access, for those of you who don't know us already. We are a UK-based company, and we've been making small cells since 2002. They are deployed today in 60 networks around the world, including the world's largest femtocell deployment in North America with AT&T. This is the AT&T 3G microcell, as they call it, which is an IP access design built by Cisco, and it connects back over the internet to an IP access gateway in AT&T's network. So that's an example of what we do. To introduce small cells to those of you who don't already know too much about them, the main idea with a femtocell or a picocell is that you can install them very, very quickly and easily inside a building, a home, an office, shopping center, hotel, to provide a very high-quality mobile phone signal. You simply plug in an Ethernet connection to the device, and they connect back over the internet to the mobile operator's network and provide a signal, a mobile phone signal, inside the building. They are real mobile phone base stations, just very small ones. So femtocells and picocells come in different sizes for different types of applications. So at the very small end, you have this sort of device. It's about the size of a Wi-Fi router, very similar, and these are designed for homes. So they will support up to 4 simultaneous phone calls, typically. And then there are larger devices. So this one we call our picocell. This is a bigger one which will support up to 16 simultaneous calls and data sessions, and that is used normally inside offices or shopping centers. And now we're beginning to see also even deployment of femtocells and picocells in metro areas, even outdoors at the larger end. There's really 2 reasons why it makes sense for an operator to use small cells. The first is all about coverage. If there's a poor mobile phone signal inside a building, then people can't use their mobile phones. Installing a small cell will enable them to use their mobile phone more and make for happier customers. So the business case is really about more use of mobile phones and customer retention. But I don't really want to talk about that business case today. I want to talk more about something which is becoming increasingly important, which is using small cells to add extra network capacity as more and more mobile data is used. And here the business case is really all about offloading traffic from the macro network and onto the small cell network. People have talked about the mobile data explosion a lot already, so I don't need to say much, but one thing I found interesting is that this is a global phenomenon. So people are using more and more mobile data on their handsets all over the world, and in particular in this region, in the Middle East, we can see that the forecast is that there's the strongest mobile data growth anywhere in the world in the Middle East and Africa is forecast. So this is a forecast from Cisco. They do this on a regular basis. They look at how they expect mobile data traffic to increase, and clearly this region is the fastest growing and will remain that way until at least 2015. So it's a problem everywhere. It's clearly a key problem in this region. So operators clearly need to offload data traffic from the macro network as much as possible to cope with this data explosion. And small cells can help in 3 different ways. The first way is that actually they are the most efficient way to provide extra capacity. They enable spectrum to be reused in smaller and smaller chunks, which is the most effective way of adding capacity. Secondly, they reduce the cost of delivering data over the network. It's much cheaper to deliver a megabyte of data over a small cell network than it is over the macro network outdoors. And the third reason is that small cells are particularly good for indoors. You can install them very quickly and easily inside buildings, and that's where most of the mobile data is being consumed. So I'm going to look at a little bit at each of those three reasons. So first of all, spectrum reuse. This graph shows a historic view of how different techniques have been used since 1950 to add capacity to networks. And you can see that creating more spectrum has added 25 times the capacity to the network. Techniques such as frequency division, modulation, and coding schemes can add more capacity to the network. But by far the most significant impact can be made by smaller cells, essentially, reusing spectrum. So instead of having one very large cell, if you divide the network up into smaller and smaller cells, you create extra capacity much more efficiently than you do with any other technique. So small cells really are the best way to add capacity to the network. Here's a quote from Ericsson, who are, perhaps not the most supportive of the femtocell idea, but yet they're saying that, as they expect a 1,000-fold increase in data usage on mobile phone networks by 2020, there is no alternative but to add what they would call picocells to the network in order to cope with that demand. You can't solve the problem with LTE. You can't solve the problem with clever coding schemes. You can't even solve it with more spectrum. You need all of those things, but you also need small cells. So the second reason is about cost. And so there's a big concern, and there has been for a long time, that the cost of delivering data is going to be higher than customers are willing to pay. So as the amount of data that a subscriber consumes, the average amount of data increases, the cost of delivering that data over the network goes up beyond what that customer is willing to pay. So that's one of the drivers to introduce LTE, because, of course, it's cheaper to deliver data over LTE. But then again, customers will use more data over LTE because the experience is better, and you end up with the same problem again. So it's vitally important to make the cost of delivering data as cheap as possible using whatever techniques are available. And small cells are very good at this. So first of all, they offload the radio network, the outdoor network, and that makes more space for outdoor users. And as part of that, they offload a particular bottleneck, certainly in 3G networks, which is the radio network controllers. So the RNCs in a 3G network are currently under a storm of smartphone signaling traffic from background applications which are running continuously on smartphones. And that's causing issues in mobile phone networks. If you can offload not only the macro cell tower, but also the RNC, that's a significant saving. The operator doesn't need to grow that infrastructure so fast to cope with the data. And small cells actually also can offload the core network as well, using a technique known as SIPTO, which is currently being standardized. And that the content goes via the internet, through the operator's core network, through the RNC, over the transmission network to the macro cell tower, and then via radio to the handset. So quite a long route, some expensive equipment in that path. With a femtocell deployed as they are today, what happens is the content goes from the internet, it still goes through the carrier's core network, but then offloads the RNC. It goes through a femto gateway instead, over the fixed internet to the femtocell and then to the phone. So we're offloading the RNC, offloading the macro cell. And with SIPTO, you get an extra benefit because the access point itself is directly connected to the internet in the home or the office. So you can actually send the content directly from the internet through the broadband network to the femtocell and to the phone, offloading the core network, even offloading the femto gateway. And one thing that's interesting about this, though, is that that's the user plane traffic, but the signaling traffic is still in the operator's domain. So the operator can still provide policy rules, can still charge for data if they want to, but the data traffic is offloaded. Of course, that's the vast majority is, if you're watching a YouTube video, you don't need to send that traffic through the core network, through the RNC, through the backhaul network, or the cell tower. So the third reason why small cells make a big difference is that they can be very targeted towards indoor usage. And what we're finding with mobile data is that the vast majority of data is consumed indoors in hotspots. And this is some analysis by Informa Telecoms. They have seen that I don't know if you can read this, the blue at the bottom is the amount of mobile data traffic consumed in homes. Today it's at about 50% of all mobile data is generated inside homes, and then offices above that. So we're up at around between 70 and 80% of mobile phone data on 3G networks is generated inside homes and offices in buildings. So how do we, that causes quite a significant problem because indoor users have a disproportionately bad effect on the mobile phone network. So the way that a 3G network works, what happens is that all of the mobile phones inside a cell are essentially sharing the cell power from the macro network. So you can see here that there's a maximum amount of power that the cell can support, and typically phones that are at the edge of the network need a lot more power than phones that are close to the macro base station. But let's see what happens when this green phone goes indoors. In order to serve that green indoor phone, the signal has to penetrate the walls of the building, and the amount of cell power required to do that increases very significantly. So that affects everybody else in the cell. There's now no longer enough power to serve everybody, all these other phones in the cell, to the same level. So maybe the guy at the edge of the network gets kicked off, the cell breathes and gets smaller. Maybe the service provided to other phones has to be reduced in quality. And so what's really important is that you get the indoor users off the network as quickly as you can. So if we don't have any solution for that, then the only way to grow the capacity of the network is just by adding many more cells, or upgrading the cells to support more users. But you can avoid the cost of doing that if you can take the indoor users off the network by using an indoor cell. Then the cost of upgrading the outdoor network or the requirement to do that is reduced. So here's an analysis by Signals Research Group in the United States, which shows how the cost of providing higher and higher data rates to indoor users increases as you want to provide faster data services. So the green bars here show the cost of providing, for 90% of indoor users, the cost of providing downlink data rates of 1 megabit per second, 2, 4, 8, and you can see the costs are growing out of control as you increase the data rates that you want to deliver to those indoor users. This is for typical Western Europe 2100 megahertz HSPA network. That's where the analysis was done. But with small cells, the cost remains static. You put a small cell in and you give all those indoor users the full data speeds, and the cost doesn't grow as you want to increase the speeds offered. So really, femtocells and picocells are the most cost-effective way for an operator to provide 3G high-speed data services inside buildings and 4G in future. But there is, of course, another way to solve the problem. There's a couple of other ways. To some extent, you can scale down the macro network and provide in-building coverage through that. You can go a certain way with that. But the main alternative is, of course, Wi-Fi. Wi-Fi is equally good as femtocells in offloading the macro network and offloading the core network. And smartphones, which are causing much of the problem, along with laptops, all have Wi-Fi embedded today. So Wi-Fi is another viable way for an operator to solve the problem of the data explosion, but it doesn't really solve the problem completely, partly because it's very difficult for a carrier to get their own Wi-Fi network into private buildings, into offices, shops, homes, and so on. So that's a challenge. Secondly, there are other smaller issues, such as if a subscriber is using Wi-Fi, it's difficult for an operator to bill for content, for instance. It's harder for them to know who the subscriber is and to put charges for content on the phone bill. And equally, Wi-Fi does nothing to improve the carrier's core services, so whether it's voice or SMS, If there's a problem with those, then Wi-Fi doesn't help at all, at least not without a significant investment in technology such as UMA, which really hasn't taken off. So Wi-Fi can be used, and typically is being used a lot in carrier hotspots. But what we're seeing is that operators are really adopting dual network strategies. They're deploying both Wi-Fi in their own carrier Wi-Fi hotspots, and they're also deploying small cells in other places, and even in the same places. And AT&T is a good example of this. So one thing that they're doing is they are installing connection manager software in their iPhones, which will automatically connect the customer to the Wi-Fi network, their own Wi-Fi network in a hotspot, such as they have in Times Square, for instance, in New York, and lots of other places. But equally, AT&T is using Femtocells as well to help solve the capacity problem. And so as the quote here from Ralph de la Vega, who's the CEO of AT&T Mobility, he says, Wi-Fi and Femtocells, it's a combination which is going to help us manage bandwidth and provide a great experience. So Femtocells and Wi-Fi really are complementary, and what we're seeing is operators using both techniques. Okay, thank you very much.
Any quick question from the audience? Yeah, there is one over there, please.
IP Access can't sell a Femtocell to a building owner and have them install it and provide service for multiple operators. It doesn't work like that. Technically, one day it probably will, but today the industry is not at a stage where that's really practical today, because the Femtocell standards are, whilst they're now in place, the systems that are out there are all migrating towards the industry standard. They're not, the standard's not mature and deployed everywhere today. So actually, the Femtocell would need a different connection to each operator, not quite standard. And so that's one issue. A second issue is that you have to sort out the management. So if the cell belongs to multiple operators, then if one operator shuts it down for maintenance, the other operator doesn't know. That's kind of not sensible. So I think I can see a world in the future where you will be able to buy a device which supports multiple operators, but today the industry is not quite mature enough to support that. So yeah, operator specific today.
Eventually, a final question from me. This has been around for 4 years, Femtocells. I think you're one of the leading supplier in this area. What kind of challenges did you face? A lot of operators were very pushy at the beginning. There was a hype on that. But finally, if you look at the number of deployment or the scale of deployment, it's rather minimal still. So we're still in the beginning. So why that? Why it's not happening? So the capacity issues, many of them ran into that 3 years ago already by activating one carrier, the second carrier, and now they're on the last carrier. Yeah. So why?
That's a very good question as well. So 3 or 4 or 5 years ago, there was a lot of hype about Femtocells because we could demonstrate that they worked. But typically any new technology takes a lot of time to introduce. So Gartner has the concept of the hype cycle, where at the beginning there's a lot of excitement because you can see the technology is there, but it takes much longer than anybody thinks to actually solve all of the technical problems and reach a mass scale. Problems such as minimizing interference with the macro network. Very complex technology had to be developed to allow that. The plug-and-play provisioning capabilities. So, and then having got that working, providing scale. So it has taken a long time. There's no doubt about it. But we are ready today. So.
And what about the cost point? I mean, the technical challenge were clear from the beginning. Also, the fact that you use one Femtocell in one place and you do not move it elsewhere. You can take it everywhere with you, Rome, obviously, for free, which was the major gag at that time. I remember the guy from StarHub who launched Femtocell 2 years ago was coming to Dubai and was showing how he can make phone calls from there. So what about the cost points?
I mean, cost point today, obviously it varies depending upon the size of the device, but I don't think it's a major barrier to the business case. So, the price of, operators can afford to give these away. They're cheap enough to do that. So in Japan, in America, in France now.
They're still around $100. So the question is, compared to Wi-Fi router with 20.
Oh, yeah.
it's still 5 times more. So
Yeah, yeah. It's still much more expensive than Wi-Fi. That's absolutely true. But they're cheap. They're cheap enough for operators to. AT&T has hundreds of thousands, and they give them away to high-value customers as a way to ensure customer satisfaction. So I don't think the cost point is quite so important. Also, just on the other issue you had, the concern about being able to use the Femtocell abroad and make free phone calls, that actually doesn't happen because Femtocells are quite clever in that the first thing they do when you plug them in is they listen to the surrounding radio environment, and if they detect foreign mobile country codes, or even if in North America, if they detect that they've moved out of a region of coverage.
I know.
Yeah, that one's solved. So unfortunately for all of us who travel, you can't use a Femtocell.
You can travel with your cell. Okay, thank you very much. Thank you again.